We've defined vectors, so now let's talk about how we add vectors. In this video lecture, we're going to talk about adding vectors graphically, so that is our objective here. The addition of vectors, as you might imagine, needs to take into account both their directions as well as their magnitudes. So there are two methods for adding these vectors graphically. Slide this up a little bit here. The first method is the polygon method. Okay, in the polygon method, we join head to tail, and we keep the magnitude and the direction unchanged. The sum we're going to be calling the resultant vector. If you want to underline the word result, the sum is the result is the sum of the vectors, the resultant vector. And usually the vector r is used to indicate the resultant vector, which is drawn from the tail of the first vector being added to the head of the last vector being added. Let's see a couple of examples of how this is done. So example 1 here, we want to add vector A to vector B. And again, when writing, a letter with an arrow above it indicates a vector. Okay, I'm going to use my ruler so I can be a little more precise. We're going to say that vector A, in my case, is a 1-inch vector that looks like that. And vector B is going to be a 1/2-inch vector that looks like that. And I want to add vector A to vector B. Okay, to make things a little bit easier and keep things separate. Okay, so what do? This is my first one, so I'm going to connect the tail of this vector to the head of this vector. Okay, so let's see. I'm going to copy the direction of vector A, keep vector A the same, and I'm simply going to attach vector B head to tail. I'm going to try to keep my direction. I'm not using a protractor, so I'm going to try to make it as accurate as I can. It's a 1/2 inch long, so there it is, added on, and that is vector B. Okay, excuse me. So we've joined head to tail. All right, and so now that we've done that, I'm going to copy that again as I looked at kind of providing you with some steps here. So this is vector A. Vector B, again, this is not going to be perfect, but I think you'll get the basic idea. There's vector B. And so now, the resultant vector, the sum, is drawn from the tail of the first vector to the head of the last vector. So here's the tail of the first vector. Here's the head of the last vector. I'm going to connect those. And this is the sum of the vectors A plus vector B is called the resultant vector R. And so if I want to come over here and I can just draw R by itself, let's see, R is about 1 inch and looks like a 1/4-ish. So I'll draw R, 1 1/4 inches approximately. That's the sum. Okay, so we're going to connect head to tail. And then when we're all done connecting head to tail, we'll draw the vector from the initial head to the final tail, and we'll have our sum. Let's take a look at 3 vectors, and I won't get quite as precise with this one, reasonably precise. Vector A plus vector B plus vector C. Let's add up these 3 vectors. Okay, we'll make A the same. I'll make the same size and direction, so there's A. We'll have B go off this way. Looks like I'll do it as a 1/4 inch. So there's B, and we'll have C go off this way at a 1/2 inch, and there's C. So we want to add these 3 vectors. Oops, I forgot the arrow on C. Okay, let's add these 3 vectors. Okay, whoops, let's go with A. And again, since I'm not using a protractor to get the angles precise, this is not going to be precision, but again, you get the idea. B is going off this way, and I think it went off this way. Let's see, what was it again? It was 1, yep, okay. Went off this way about like there, so there is B. I added B to A, now C is going off this way. Looks like that's about C. So here is C. Okay, so A, head to tail, head to tail, head to tail. When I'm all done, connect the first head to the last tail. And here it is. And this is the sum, the resultant vector. And again, I will draw that one by itself. Looks like this one is about 1 3/8 inches. And if you want to see that vector all by itself, there you go. So head to tail, head to tail. When you're all done doing head to tails, the first head, the last tail is the sum of those vectors graphically. So that's the polygon method. The other method is a parallelogram method, and it applies to when you have simply 2 vectors. So this is 2 vectors only in the parallelogram method. And this method says we place the 2 vectors being added tail to tail, and then we form a parallelogram that includes those 2 vectors as sides. The resultant vector then, the sum, is the diagonal of the parallelogram, with the initial point being the common initial point of the 2 vectors being added. Okay, let me give myself a bit more space here. Alrighty. So I'll just do one example of this because I think you get the idea pretty quickly. Let's add vector A plus vector B. And I'll copy what's up there in terms of, I'll keep my A as being an inch vector going off to the right. Why not? So this is vector A, and I'll make vector B be again a 1/2 inch vector going up to the right a little bit. Okay, so those are my 2 vectors. I want to add those 2 vectors together. Okay, so this method says match up their tails. Okay, so here we go. There's vector A. Okay, so now here, let's try to keep this angle reasonably consistent. Again, pardon the lack of perfection without a protractor. Okay, so I matched them up. Now I simply draw a parallelogram. Okay, so I will use these 2 as sides, and I will draw a parallelogram. Alrighty. Let's see here. So there is my parallelogram. Okay, so there's my parallelogram. And then I simply, the resultant vector, the initial point being the common initial point and the end point being right here. So I simply go to here, and this is my resultant vector, or if you want to see it by itself, 1 1/4-ish. This is the resultant vector. This is the sum of the 2 vectors A and B. If I come down a little bit here, I think I can make this work. Well, not really, but you can see I kind of copied this one, so there's that, and you can compare it to this one. You can see those are the same thing. So there's how you add vectors graphically using one of two methods, either the polygon method, which works for any number of vectors, or the parallelogram method, which works for two vectors.